Hi, welcome back to the online lecture. In last lecture, we have discussed about the conductometric titration. What is conductometric titration, and how the conductance of the solution is measured by means of the using the conductometer. Now, today's lecture, we are going to discuss about the types of conductometric titration. So let's begin with the types of conductometric titration. So student friends, today we are going to discuss about the types of conductometric titration. So there are generally different types of conductometric titration, that is acid base titration, redox titration, precipitation titration, oxidation reduction titration, etc. In the first, that is what the acid base titration. Then see, the in acid base titration are typically, that is what particularly well adapted to the conductometric endpoint because of the very high conductances of the hydronium ion and hydroxide ion involved in these reactions as compared to the other types of reaction. So in acid base titration, the active species are, or the conductance is nothing but the measurement of the what it is the movement of ion. So the highly movable ions, that is hydronium ion and hydroxide ions are there. So this is a very applicable method for the acid base titration, is nothing but that the conductometric titration. So in the following uh, titrations, that is what acid base titration is discussed, but there is what the four types of acid base titration, depending upon the strength of the acid, that is strong acid with strong base, strong acid with weak base, weak acid with strong base, and weak acid with weak base. So there are generally four types of the acid base titration. Let's see the strong acid and versus strong base acid base titration. Let us consider the titration of the strong acid, that is nothing but HCl hydrochloric acid with the strong base NaOH sodium hydroxide. Then in the solution, that is what the HCl behaves as a H plus and Cl minus ions and Na plus OH minus ions. So after the reaction, that is what the when we add the HCl, NaOH to the HCl, then the net reaction is the what neutralization reaction, that is nothing but Na plus Cl minus plus H2. Here what H plus and OH minus get combined to form undissociated water molecule and neutral salt molecule. So at the start of the titration, the acid solution has a high conductivity due to the highly mobile hydrogen ions, that is H plus ions, because at the initial stage there is only H plus and Cl minus ions in the solution. So highly mobile H plus ions is responsible for the higher conductivity. So at the what initial stage, the conductivity of the solution is high due to the highly movable H plus ions. Then the chloride ion will be smaller because of the less mobility and as compared to the hydrogen ion. So they does not contribute to the what the net conductivity, but the higher conductivity is mainly due to the H plus ions. When NaOH is added to the HCl in a small increment or in a small installment, the highly mobile hydrogen ions are replaced by less mobile sodium ions. So, this will result in the decrease of conductivity rapidly. So, when we add the NaOH to the solution, then OH minus ions from the NaOH get combined with H plus ion and form the undissociated molecule, that is H2O, and the less mobile ion Na plus ions is what replaced by means of H plus ion. So the net conductivity is decreases rapidly. So the solution of the neutralization, that is what the at the solution that at neutralization, that is at the end point containing only sodium and chloride ions, will have a minimum conductivity because both the ions are very less movable. So the conductivity is very less at the neutralization point and will increases owing to the excess of OH minus ions, or what when this increase is recorded when the number of OH minus ions increases in the solution. So whatever we add the addition of the increment of OH minus ions after the neutralization, there is a sharp increase in the conductance is observed due to the highly mobile OH minus ions. So as compared to Na plus ion. Thus, if the conductivities are plotted against the volume of NaOH added, then we'll get the uh, following type of graph, that is two straight line, that is one is in the decreasing order due to the decrease in conductivity, and after neutralization point, that is at the intercept point, then conductivity get increased, and this neutral that the intercept is nothing but the neutralization point of that, or the end point of that titration. So in actual practice, the lines may be slightly curved due to the increase in the volume of the solution because of the addition of the reagent. Therefore, the reagent added should be at least 10 times or more concentrated than the titrating solution. So the intersection of the lines is sharp enough to get the exact endpoint. The advantage of this titration is that the very dilute solution can be titrated with almost the same accuracy as concentrated solution. So that is what the application of that conductometry. So what is the advantage of this conductometry? This what the very dilute solution can be titrated with almost the same accuracy as the concentrated solution. This is what the advantage of the conductometric titration, acid base conductometric titration. The next type of the titration is the what the strong acid with the weak base. Here what one is a strong acid and another one is a weak base. So strong acid dissociates uh, fastly and weak acid dissociates slowly. So what happened, what is the nature of the curve, or what is the nature of plot after what the titration of strong acid versus weak base, what is the end point, we will see. Let us consider the titration of HCl, that is strong acid, with the ammonium hydroxide weak base. When ammonium hydroxide is added to the HCl, the reaction occurs is that so the net reaction is what H plus Cl minus plus NH4OH, then we will get the ammonium chloride salt, that is what NH4 plus Cl minus plus H2O molecule, that is undissociated molecule. Then the highly mobile H plus ions are replaced by very less mobile NH4 plus ions, and the conductivity decreases. At the end point, the solution contains the less mobile ion NH4 plus and Cl minus. Then the addition of weak base ammonium hydroxide after the end point does not change the conductance because the dissociation of ammonium hydroxide is suppressed due to the common ion effect of the NH4 plus ion already present in the solution, and no more ion will be produced in the solution if the graph is plotted between the conductance and the volume of ammonium hydroxide solution added. So two straight lines will be obtained which will intersect at the exactly the end point of the titration. So the near the end point the graph is slightly curved, showing higher conductivity due to the acidity produced by the hydrolysis of the salt ammonium chloride produced during the titration, but this will not interfere in the locating the end point of the titration because we are extrapolating the straight line obtained before the end point and after the end point. The following type of graph will obtain after the titration of the uh, weak acid with a strong acid with a weak base. So what happen when we add the ammonium hydroxide solution to the strong acid, that is HCl, the less soluble or this less weakly dissociated ammonium hydroxide, that is what the ammonium ion, and that less mobile ammonium ion is replaced by means of highly mobile H plus ion. So whatever the conductivity decreases rapidly with the incremental addition of the ammonium hydroxide. Then at the neutralization point, uh, the conductivity remains unchanged due to the presence of NH4 plus ion, that is nothing but a common ion effect, and due to the common ion effect the further ionization of or dissociation of ammonium hydroxide is suppressed and will not get the increase in the what conductivity. So the conductivity remains unchanged after the end point, and the uh, intercept point of that two lines is nothing but the end point. So we'll get the curve like this. uh, if we plot the graph conductance versus the volume of ammonium hydroxide added, then we'll get the line in decreasing order, and uh, one line is a straight line, that is there is no change in the what conductance, see here, and here what the decrease in the conductance appear, and here what there is a no change in the conductance, so it is a stable current. So what is the this is the interception point, that is what the interception point, and this is nothing but the end point of the titration. So after the plotting the perpendicular to this, then we'll get the end point. So this is about your the uh, titration of strong acid with a weak base. The next type of the titration, that is nothing but titration of weak acid against a strong base. When weak acid is titrated with a strong base, what will the result is that, let us consider a weak acid like acetic acid is titrated against a strong base like sodium hydroxide. When a small amount of NaOH is added to the acetic acid, then the conductivity first decreases to a small extent and then increases slowly and finally rapidly after the end point. The following reaction occurs, that is what the CH3COOH, that is nothing but acetic acid, plus sodium hydroxide, that is NaOH. Then we'll get the sodium acetate plus H2, that is nothing but CH3CO minus plus Na plus H2. The initial slightly higher value of the conductance is due to the weak ionization of weak acid due to uh, acid to produce a little amount of H plus ion, which react with OH minus ion to form a small amount of NaOH added to produce a undissociated H2 and a little amount of salt, that is what the uh, sodium acetate, which ionizes completely. The salt produced suppresses the ionization of the acetic acid due to the common ion, and the conductance decreases slightly with the further addition of NaOH, which reacts with the CH3COH to produce highly dissociated CH3CO plus Na salt, which causes increase in the conductance slowly with the addition of NaOH. At the end point, only CH3CO minus and Na plus ions are present in the solution. After the end point, the highly ionized NaOH added causes the conductance to increase very rapidly because of the addition of highly mobile ions, that is OH minus ions, in the solution. When the conductivities are plotted against the volume of NaOH added, the following type of the graph results. So conductance versus the volume of NaOH added, will get the firstly what is the slight decrease in the uh, conductivity is recorded, then after that the slightly increase in the conductivity after the end point, that is sharply increase in the conductance due to the highly dissociated OH minus ions. So near the end point, the graph is slightly curved, showing higher values of the conductivities due to the hydrolysis of sodium acetate salt, and sodium acetate get what hydrolyzed into the acetic acid plus Na plus OH minus. The curvature in the conductance do not affect the location of the endpoint because we extrapolate the two straight lines before and after the endpoint to give the exact endpoint. So with the this is about the what is weak acid, that is conductometric titration uh, between the weak acid and strong base. So we'll get the such type of nature of the graph. What is the nature of graph? Nature of graph is that firstly what slightly decrease in the conductance, after that slightly increase in the conductance, and at the end point there is sharp increase in the conductance, and here what the neutralization point, here what the neutralization point, intercept point is the neutralization point. The increase in sharp increase in the conductance at the end point is due to the hydrolysis of sodium acetate ions. So this is about the three types of conductometric titration, that is acid base titration, and the remaining part of the type of conductometric titration we will see in next lecture. If you have any queries regarding this lecture, please put your questions in the YouTube comment box. I will try to answer the question. Thank you, thanks a lot, have a nice day.